So now what we're going to do is we're going to do number patterns, which is going to be question 2 till question 4, right? So we're going to start with question 2. It says the p term of the first difference of a quadratic sequence. So we know the fact that this is a quadratic sequence, and remember the fact that the quadratic sequence is going to be the terms here at the top, then the second stack is going to be the first difference, and the last part is going to be the second difference. So this is the first difference, right? So they tell us the fact that they give us the equation for the first difference, which is TP is equals to what? Is equals to 3P minus 2. That's what they gave us, right? And they tell us then the first question, which is 2.1, says determine between two consecutive terms of the quadratic sequence the first difference is equals to what? Is equals to 1450. So what did they give us? They gave us the second difference, one of the terms in the first difference, right? So they gave us one of the terms here in the first difference, which is 4050, and they want two consecutive terms. So what can we do? We can, wherever we see TP, we're gonna substitute by this. So it's gonna be TP is equals to 3P minus 2. So you're gonna say 1450 is equals to 3P minus 2. Take the 2 to the other side. It's gonna be 1452 is equals to 3P. Divide both sides by 3. So it's gonna be P is gonna be equals to 484. But they say they want two consecutive terms, so your answer is going to be between 484 and 485. Then you're done because of its two consecutive terms. So 2.2 says the fourth term of the quadratic sequence is equals to 2290. So we know the fact that T40 is equals to 2290, right? And they say Tn, right, is equals to an squared plus bn plus c. You know this is the general term for a quadratic sequence. It's the n term of the quadratic sequence, right? And they tell us to calculate for c. So what do we know? We know the fact that the first layer is the Tn, right? It's the general sequence. So the first layer is going to be where your Tn is, right? Then the second layer is your first difference, which is what? An arithmetic sequence, which is in our case they gave us as TP is equals to what? Is equals to 3P minus 2. Then the last one is the common term, right? So we can find what? We can find the last one by using the first one, right? So what do we know? We know the fact that the formulas for A, B, and C, we know the fact that 2A is equals to what? To the difference, the last difference. So it's equals to the first term here, right? Then we know the fact that 3A plus B is equals to what? To the first term of the first difference. So this term here. Then what do we know? We know that A plus B plus C is equals to what? Is equals to this term here, right? So what we're gonna do is we're gonna use this one to find this 2. Let's do that. So T1 from using this formula is going to be 3 open bracket 1 minus 2. That is going to be equals to what? That's going to be equals to 1, right? So we know the fact that here is going to be what? It's going to be 1. That's the number. So 3A plus B is going to be equals to 1. So now we need to find out what 2A is going to be equals to, right? So this is going to be the first term. So 1 is going to be here as the first term. Let me put it here in orange, right? So let's find T2. So T2 is equals to what? Is 3 open bracket 2 minus 2. It's going to give me what? It's going to give me 4. So we know that the second term is 4. Then to find the difference is going to be what? It's going to be 4 minus 1. It's going to be equals to what? It's going to be equals to 3. So this 3, because it's common throughout, is going to come here, right? So now, knowing the fact that 2A is equals to 3, let me erase this part. Let's start solving for A and B. So we know the fact that what? 2A is equals to 3. Therefore, A is equals to 3 over 2 because we divided both sides by 2. Then we know what? We know that 3A plus B is equals to what? To 1, right? Then I'm going to substitute A here. So it's going to be 3 divided by 2 plus B is equals to 1, right? Therefore, B is equals to, if I take this whole thing to the other side, it's going to be equals to negative 7 over 2. So I know that B is equals to negative 7 over 2. Then, since I can't find the top part to equate it to find C, what can I use? I can use this information that T40 is equals to 2,290. So I can use that information. So let me write the general solution now, the Tn, but now having A and B in it. So let's do that. So Tn is equals to what? To An squared plus Bn plus C. Substitute A and B, it's going to be Tn is equals to what? To 3 over 2, right? N squared plus, actually negative, minus 7 over 2, right? N plus C. But what do we know? We know this. We know that T40, right, is equals to 2,290. So I'm going to say now T40, right? So here, wherever I see N, I'm going to substitute 40. So it's going to be 3 over 2, 40 squared, minus 7 over 2, 40 plus C. But we know the fact that T40 they gave us is 2,290. So I'm going to say 2,290 is equals to, simplify this, I'm going to get, so simplify this whole thing, this part, this whole thing, I'm going to get 2,060 plus C. Then I'm going to take this to the other side. So it's going to give me C being equals to 30. Then you're done with this question. So now moving to question 3, they say the first 4 terms of an arithmetic sequence are, they give you, then they say 3.1.1, they say determine the expression of Tn. So we know the fact that arithmetic sequence Tn is equals to what? To A plus open bracket n minus 1 multiplied by D, right? So we need to find A, which is in our case is the first term, which is 65. Then we need to find D. So D is what? Is going to be 73 minus 65, right? So 73 minus 65 is going to give me 8. So therefore that's equals to D, right? So we're going to substitute A and D here. So it's going to be Tn is equals to 65 plus n minus 1 and multiplied by 8. Distribute the 8. It's going to be 65 plus 8 n minus 8. Then 65 minus 8 is going to give me what? It's going to give me 8n minus 50. It's going to be 8n plus 57. And you're done finding Tn, right? Then the second part of the question says calculate the value of the term in the 1,000 position. So we need to find T1000, right? So T1000, wherever we see n, we're going to substitute by 1,000. So it's going to be 8 open bracket 1,000 plus 57. Then when you punch this into the calculator, you're going to get 8,057. Then you're done with this question. Then 3.1.3 say calculate the sum of the first 1,000 term. So we need to find Sn at the 1,000 term, right? So Sn is going to be equals to n minus 2 open bracket. I'm going to use the one that has the first term and the last term. So we're going to say A plus L. The reason why I'm using that, they say the first 1,000 term, we know what's the 1,000 term is 8,057, right? So we know that n is equals to 1,000, right? Then A is going to be equals to the first term, which is 65, and L is going to be equals to 8,057. Then we're going to substitute. So S1000 is equals to, therefore when you punch this into the calculator, your answer is going to be, then you're done with this question. So now going to 3.2, it says an arithmetic and geometric sequence have the same first term. So if it has the same first term, meaning A for both of them is equals to 5, right? And they say the common difference, which is for the arithmetic, and the common ratio have the same value. So meaning in this case, D is equals to R, and let's say D and R is equals to X. They have the same one, right? And what do they tell us? They tell us that the fifth term of the geometric series, like this geometric series, is equals to 80. So we know the fact that from the geometric series that T5 is equals to 80, and in bracket I'm going to say geometric, I'm going to say geo, right? And they want us to determine the first 3 terms of the arithmetic sequence. So I need to set up a geometric and arithmetic sequence. So let's do that. So for the, for the arithmetic, I'm gonna say 5, which is the first term, right? Then you know the fact that to find the difference, you need to take the second term minus the first term. So now we're gonna add by the difference, right? Which is, in our case, our difference is x, so it's gonna be 5 plus x, right? Then for the third term, it's gonna be what? It's gonna be this term plus x again, so it's gonna be 5 plus x, making it 2x, making it what? Making it equals to 5 plus 2x. So let me write it like that. So this one is going to be what? 5 plus 2x. And this one is what? It's going to be our arithmetic sequence. So I'm going to call it AS. Okay? So the second one for the geometric, to find the ratio, we need to take what? The second one divided by the first one. So if the first term is 5, therefore we're going to multiply, because to find the ratio, we need to divide. So this is going to be the same as saying 5x, and for the third term, it's going to be saying 5 multiplied by x, right? Because we're multiplying. So this is the same as what? 5x squared. So I'm going to rewrite it. So it's going to be 5x squared. And this is for what? For GS, which is the geometric sequence, right? So what we're going to do now is that we need to find the first, second and third term for the arithmetic. But here, what did they tell us? They tell us that the T5 is equals to 80. So let's find the general solution here. So we know the fact that the general solution for arithmetic is going to be Tn is equals to what? Is equals to a r n to the power 1, right? What's our a? Our a is 5. And what's our r? Our r is going to be x to the power what? To the power n minus 1. But what did they tell us? They tell us that T5, right? So wherever we see 5, we're going to substitute by what? By wherever we see n, we're going to substitute by 5. So we're going to say 5 is going to be 5 minus 1. They told us the fact that T5 is equals to 80. So here I'm going to say 80 is equals to 5x to the power what? To the power 4. Divide both sides by 5. It's going to be 16 is equals to x to the power 4. Then you're going to say the root of 4, right, of 16 is equals to the same thing here, because we want to get rid of x to the power 4. Then since the exponent here is positive, this one is going to be plus or minus. Remember, since this one is an even number and the exponents is what is even, here's going to be plus or minus. So our answer here is going to be plus or minus negative. Plus or minus 2 is equals to x. So our answer is going to be x is equals to negative 2, or x is going to be equals to what? It's going to be equals to 2, right? So now we know the fact that for our arithmetic sequence here at the top is we need x to find the second and third term, right? So let's do that. So we're going to take 4 when x is equals to what? 4 when x is equals to negative 2. So let me do it in another answer. So 4x equals to negative 2. Our sequence is going to be 5. Then you're going to say 5 plus minus 2 is going to give me what? It's going to give me 3. Then for the last term, it's going to be 5 plus 2 open bracket negative 2. It's going to give me what? It's going to give me 1. Then or, right, because it's or, 4x equals to positive 2 is going to be 5. Then it's going to be 5 plus positive 2 is going to give me 1. It's going to give me 7. Then it's going to be 5 plus 2 open bracket multiplied by 2 is going to give me 9. Then you're done with this question. Then now moving to the last question, it says calculate the value of y if, then they give you the sequence, right? So we see the fact that this summation, the sign, right, it represents Sn, right? So this sign represents Sn, right? It's very important to know that. Then what I'm going to do is I'm going to break it down into portions to basically find the Sn for each, then equate them together to find the value of y. Let me fix this. So now looking at the first portion, which is this one, right? They say, right? So they tell us this. What does this one mean? Since this is multiplication, right? that the p that you need to substitute is multiplied. This one is what? This one is an arithmetic sequence. So since if it's an arithmetic, we're gonna find p in our case, because it's p here, so this is going to be equals to what? To this part. It's going to be equals to this part. So it's going to be 4y plus 3p, right? So we need to find the sum of TP, right? We need to find SN here for this one, right? So to find SN in this case, it's going to be what? Our SN, since it's an arithmetic, we need what? We need I'm going to use the one that has the first term and the last term. So we're going to say n divided by 2, open bracket, a plus L, right? So what do we need? We need n, right? We need a, and we need the last term, right? So to determine n, right, we see the fact that p starts at 1 and it ends at 5. So we check how many terms they are. So if we say 1, 2, 3, 4, 5. So we see the fact that from 1 till 5 we have how many terms? 1, 2, 3, 4, 5. So our n is going to be equals to what? To 5. Right? Then we need what? We need a. And a is equals to T1, right? Using TP. So let's do that. So let's find our T1. So T1 is equals to 4y plus 3. Then wherever we see P, we're going to substitute by 1. So we're going to say 1. Therefore, this is equals to 4y plus 3. Then what is our last term? Our last term, we're going to use what? The n. We're going to use the 5. But now we're going to use here. This one is going to be equals to T5. That's our last term from this n. Right? So it's going to be what? Wherever we see P, we're going to substitute by what? We're going to substitute by 5. So it's going to be T5 is equals to 4y plus 3. Then you're going to say 5. Therefore, 4y plus 15, right? Then we're going to substitute this 2 here in the formula. So we're going to find S what? S5 is going to be equals to what? 5 divided by 2, open bracket, is going to be 4y plus 3, right? Then you're going to say plus 4y plus 15. So here in the bracket, we're going to group like terms. So it's going to be 5 divided by 2. Then here we're going to have 8y plus 18, right? So we're going to distribute the 5 to the power 2. So we're going to have 20y, right? Plus 45. And that's for this part. This one, I'm going to do it in green so that we can see. This part is going to be what? It's going to be 20y plus 45. So that's the green one, right? So now moving to the second portion, which is this one, we need to find the SN for that one, right? So we have that. I'm going to just do it in orange so we know which one I'm indicating, right? So we know the fact that TK is going to be equals to what? It's going to be equals to this. So it's going to be 3 multiplied by 2 to the power k minus 1, right? So since this is an exponential, this is going to be a geometric sequence. So we need to find Sn of a geometric. So it's going to be a, open bracket. Then from here, what do we see? We see the fact that we need to find A, right? And we need to find R, and also we need to find N. So I'm going to start with N, right? With N, we see the fact that our sequences start at what? Starts at K is equals to 4 and it ends at 7. So you're going to say 4, right? 5, 6, then 7. Then you're going to check how many terms. It's 1, 2, 3, 4. So N is going to be equals to 4. So this is 4 terms. Then R. Then our R is which one? Is the one that has the bracket, the one that has an exponent that's inside the bracket, which is in our case is 2. So R is going to be equals to 2. So here in our case, A is going to be equals to T4 because of it starts at 4. So you're going to say A is equals to T4. So we're going to find T4, right? So wherever we see K, we're going to substitute by 4. So it's going to be 3 multiplied by, it's going to say 4 minus 1. When we punch that into the calculator, we're gonna get 24, right? Then we're gonna substitute whatever information that we have here. So we're gonna say S4 is equals to what? A is 24, open bracket, is gonna be 2 to the power 4 minus 1 divided by 2 minus 1. Punch this into the calculator, you're gonna see the fact that this Sn is equals to 360, right? Then you're gonna take this 360 and this is gonna be the second part. Then now we want to do the last part, which is I'm going to do in another color. So now I'm going to do this one. So the last part is this one. We see the factor is S infinity. So we need to find S infinity. S infinity is always associated with the geometric, right? So the formula for S infinity is what? Is A divided by what? By 1 minus R. So here what do we need to find? We need to find A, right? And we need to find what? R. That's the only two that we need. But our J in this case is going to be equals to what? To this portion. So it's going to be 1 over 3. Then you're going to say J minus 1. So here, since it starts at 1, A is going to be equals to T1. So wherever we see a J, we're going to substitute by 1. So T1 is going to be equals to 1 over 3, right? Then it's going to be 1 minus 1. So therefore, it's going to be equals to 1. Then here, R is equals to what? The one that's inside the bracket, which is in our case is this one. So it's going to be 1 over 3. Then we're going to substitute this whole terms here in the formula. So it's going to be equals to what's A? A is 1 divided by 1 minus 1 over 3. Punch this into the calculator. You're going to get it to be 3 over 2. So this portion is going to be what? It's going to be 3 over 2. So now what you're going to do is you're going to combine your green, orange and pink together. So you're gonna say 20y plus 45 plus what? Because of there's a plus 360 is equals to what? Is equals to 3 over 2. Then you're gonna take the 45 and 360 to the other side. So it's gonna be 20y is equals to, so 20y is gonna be equals to, it's gonna be equals to minus 807 divided by 2, right? Then now we want to get rid of the 20, so divide both sides by 20. So y is going to be equals to negative 807 divided by 2 divided by 20, right? Because it went from multiplication, it goes to the other side, it becomes division. Therefore, y is going to be equals to negative 20, 175. Then you're done with number patterns.